This is Project 1.3, a counting circuit by Liam Northup. This is step 1, the button input. When the PBNO is not pressed, current flows through the LED, which is represented as our output, and it is high. Although when the PBNO is pressed, current is pulled to ground and the LED turns off. This will serve as our input in the next step, which is the NAND gate oscillator. This is step 2, the NAND gate oscillator, or NGO. When the PBNO is pressed, the output oscillates signal, and when the PBNO is released, it continues oscillating. This duration is because of one of the RC networks. RC1 controls the duration of the clock signal, and then RC2 controls the frequency. This will serve as our clock signal input for the counting circuit. This is step 3, the decade counter. This chip works by when a clock signal is presented, outputs Q0 through 9 take turns turning on at the frequency of the clock signal. In this project, we will not use these, but use its divided by 10 output to reduce the frequency of the clock signal for the 4510 BCD chip. This is step 4, the up-down binary counter. When the PBNO is pressed powering the NGO, the counting advancements are now displayed in binary via 4 LEDs. The circuit also introduces 2 inputs, a PBNO switch which connects to the reset pin, which when pressed resets the count, and a slide switch when presents high to the up-down pin counts up, and when low counts down. This is step 5 and 6. In this step, when the PBNO is pressed powering the NGO, the counting advancements are now displayed in decimal notation on the 7-segment display. There's also a reset pin, which when pressed resets the count, and it is counting backwards because the slide switch is presenting ground to the up-down pin. This circuit works because the output of binary on the 4510 is now an input to the 4511 chips, which converts it into decimal notation and provides 7 outputs for the 7-segment display, now displaying the counting advancements in decimal notation. This is step 7, a counting circuit. This is our final device, which has 3 inputs. When switched on the slide switch, it powers the device. Next is the PBNO, which powers the NGO, creating a clock signal to the decade counter, which divides that clock signal by 10 and then puts into the BCD converter, which is then decoded by the decoder and is displayed on the 7-segment display. The other slide switch is connected to the down-up pin on the BCD converter, which when switched counts down instead of up. This is the dual-digit counting circuit, which essentially adds another counting circuit. We can see that it counts backwards. This is because the slide switch presents ground to both up-down pins in the two 4510 BCD chips. We can also see that once we press the PBNO, it resets both counting. This is because the PBNO is connected directly to the reset pins of both circuits. This circuit works by essentially adding a new counting circuit in which we take the clock signal directly from the NGO instead of running it through a decade counter, meaning that it counts at 10 times the speed of the other one, which creates dual-digit counting. We can also see that we connected the reset and up-down pins to the same inputs as on the first chip, and then the BCD is connected right into the driver, which is then connected to the ones digit, and this creates 2 digits, 2 counting circuits, one operating at 10 times the speed of the other one.